Okay. All right. So, welcome to the third week of UMTYMP Prep. Now, this week we're gonna go over geometry. So, again, our class is gonna be similar to the previous two ones, and we're gonna first have our lecture, then we're gonna have a mock test, and we're gonna have a test review. Since there was no homework last week, we won't be reviewing any homework. Your homework was basically just to correct your mock test last week. So if you haven't done that yet, be sure to do that because the actual UMTYMP entrance test is coming up very soon in April. So be sure you're preparing a lot for that. So reviewing the previous mock test, correcting your wrong answers will definitely help you with that. So okay, so I see a question in the chat. It says, okay, yeah. So the today's mock test, I will post the PDF of it once it is time to do the mock test. So yeah, it will have the PDF once we're ready. Okay, so today's topics is geometry, as I already mentioned, and we're gonna go over a few principles like perimeter and area, angle rules, and circles, and some other general concepts. So on the UMTIUMP test, there are some little geometry tricks or little geometry things that they want you to know. And we're going to go ahead and show you most of them. We're trying to cover as much of those topics and tricks as we possibly can. But since geometry is a pretty big topic and it's impossible to really cover everything in only 1 hour of lecture, I would highly recommend learning other geometric principles and geometry outside of class somehow. So like, for example, Khan Academy is a great resource, or like any online textbooks that you have. It's just a great way to learn more of these geometric principles or basic geometry stuff. Okay, well, that being said, we'll still try to cover as much as we can. So again, I think all of you guys already joined the Google Classroom, but if you haven't yet, be sure to do that. But I think you're all in it, so that's great. Okay, so now we actually have one more new tutor joining us today. It's Ethan Zoe. So Ethan, do you want to go ahead and unmute and introduce yourself?
Hello, um I'm currently in eighth grade. I'm in Wayzata Central Middle School. I currently am enrolled in UMTYMP and I scored a 47 out of 50 on the entrance exam. And some hobbies that I have is tennis, politics, and gaming.
Thank you. So Ethan Zoe worked really hard this weekend to he actually wrote a lot of the mock test questions today. So a lot of the questions that you see today are written by him. So if they're good, be sure to let him know and congratulate him or whatever. And I promise you they're good. I looked over them and they're really good. So yeah. And if you have any questions, again, I probably won't be looking at the chat that much. So you can either ask Kevin or Ethan, and they'll be happy to answer your questions. Or you can ask the question to everybody, and maybe another student might have the answer to your question. Okay, so I'm gonna go ahead and go to an online whiteboard now. And the very first thing we're gonna learn is area and perimeter. So maybe you guys already know some geometry already, but the one thing that I remember that was on my UMTMP entrance exam was an area and perimeter question. So this is definitely a very important concept. It comes up in a lot of different questions, either in word problems or maybe indirectly through like it's one step of a bigger problem. All right. So does anyone already know how to calculate, let's say, perimeter? Is anyone familiar with calculating perimeter already? So maybe many of you guys already know how to do it, but just as a quick review, to find the perimeter, we just want to add up all the sides. So let's say we have a square. To find the perimeter, let's say the side is 1, so all 1. All you have to do is add up every side. So it's 1 plus 1 plus 1 plus 1, and that's 4. All right, so that was a pretty easy example. Now, let's say I have a shape that looks something like this. Well, finding the perimeter is the exact same way. Even though the shape looks really funky and it might look hard to calculate the perimeter, as long as I know all the sides, I can find its perimeter. I just have to add it all together. So let's say this is 3, this is 2, right here is 2, 2, 2, 2, 2, 2, 3, 1, 1, 1, 1. Right? So this shape obviously has a lot of sides. It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 sides. But finding the perimeter isn't too hard. You just have to add up all the sides. Okay, so because of this, there are some tricks that you can do to find the perimeter of some shapes. So for example, maybe they'll have a question like quantity A and quantity B. Let's say quantity A, they give you this shape right here, right? And assume this is drawn to scale. I'll try to draw it to scale as best as I can. So let's say they give you a shape like this, right? And they say this side has side length of 1, this side has side length of 2. That's actually not to scale. So I'll just say this is also 1. And let's say on B, they have a shape that looks like this. And let's say the side length is also 1 here and 1 here. And well, now they say quantity A is the perimeter of the first shape and quantity B is the perimeter of the second shape. Now, how would you solve this? Now, the correct answer is C. And well, can you see it? Well, we know how to calculate the perimeter of B, right? Because it's just a square slash rectangle. So it would just be 1, 1, 1, 1, or 4. But for A, we don't like know how long this is, right? We don't know how long these values are. But that's fine because if you really think about it, this side length right here, which I'm going to highlight in red, right? This side right here, I can just shift that here, right? That doesn't change the perimeter because I'm going to add it anyway. That will change the area though, but this won't change the perimeter. So if I do that, oh, let me try to get rid of yep. So if I do that, now let me try to find a tool to erase that over there. Is that possible? Can I erase that? Maybe I just have to draw. Well, maybe not. Okay. Well, if I do that, we can see that this kind of looks like the shape over here, right? Now, what if I also do that for this side right here? I just shift it up here. Boom. Now, if we kind of ignore these scribbled out things, we have the same exact shape. So we know that their perimeters are the same. So the first trick to learn is that you can kind of shift sides around without affecting the perimeter of the shape. You will change the shape, right? The shape will be a different shape, but the perimeter will be the same. All right. So that's one of the biggest perimeter tricks and definitely something that they might try to use to get you on the real test. So let me give you guys a practice problem. So let's say over here, quantity A, we have this shape. In quantity B, we have this shape. And let's assume that this side is side length of X, this side is side length of Y. And same thing for the second one. So which quantity is bigger? That's right. I'm seeing a lot of C's, and that's correct. So it's the exact same thing as the last problem, right? So it is C. And why is it? the exact same? Well, because again, this will take a lot more steps now, but we can shift all of these. We can shift this to be here, and we can move this all the way there, this all the way there, this all the way there, and we end up having a completed wall, basically. That's the same as here. And for all of the horizontal ones, we can shift them all up. And boom. And now we can do the exact same thing for the one over here, and now it's all the same. So it's C. Okay. So this is a great example, but with all tricks, there's also some exceptions. So let me show you an exception. All right. Let me ask. Now, this is going to be a question. I'm telling you that this is an exception. So don't say C because it's not going to be C. But the exception to the perimeter rule, remember, the only reason why these two have the same perimeter is because I shifted some sides, right? So remember, if you're ever in doubt, make sure you shift sides to get the same shape. All right. So now back to the counter example. Let's say the first shape looks like this, and the second shape is just a normal rectangle. And let's just say that they have the same dimensions again. So which quantity is bigger, A or B? So remember, it's not C because I already told you it was a counterexample, but why? You might think that, oh, I could just shift this side and then boom, it's the same rectangle, right? But no, it's actually not because there's these two extra sides. So I can still do the shifting, right? That will preserve the perimeter. But once I shift it, I see that it's the same rectangle, but it has the extra two sides right here. These two sides are adding more perimeter. So that's why A is bigger. So make sure that when you're doing these perimeter comparisons, if you're ever a little bit in doubt, make sure you go back to just shift the sides, make sure that it's the same because if you shift the sides, the perimeter will be preserved. That's a guarantee. But it doesn't mean that they're going to be the same. They still could be different. Okay. So now let's go into area. So I'm sure some of you guys already know how to calculate area, right? So for a square, the area, let's say the square has a side of S. The area of a square is S squared. All right. That's just something you should remember. That's basically a definition. You just have to know by definition the area of a square, and a square is a shape with, you know what a square is, right? All four sides are the same. They have 90-degree angles, stuff like that. But basically, if we have a square, the area is S squared, the side times itself. So the side squared. So you guys probably already know that, right? So let's move on to maybe something a little more challenging like a rectangle. So let's say I have a rectangle with length L and width W. So what is the area of the rectangle? Well, you guys might know this one as well, but the area of a rectangle is length times width. So it's very similar to the square, right? Because a square is a rectangle. Maybe you guys have heard this before, but a square is a rectangle, but not all rectangles are squares. So there we go. And now maybe let's move on to a harder one. What about a triangle? And let's say that this triangle is 90 degrees, a right triangle. It has a base of B and a height of H. So what is the area of a triangle? So this one is a lot harder. It's not exactly, maybe some of you guys don't know this yet, but the area of a triangle is base times height over 2, or 1/2. I like to write it this way, 1/2 base times height. And you can just remember this, but if you want to know why, it's basically half of a rectangle, right? Pretty neat. It's just half a rectangle, so it's half the area of a rectangle. Okay, so but that's for a right triangle. Now what if I have just a general triangle that's not right? So this is not a right triangle. So how do I find the area? Well, I'm going to tell you that the formula is the same, but we need to find the base and the height. So we know the formula is going to be 1/2 base times height, but we need to find the base and the height. So to find a base, I can choose any side to be the base. So let's just choose this side right here because I like this side. So I'm going to choose this side to be the base. And now for the height, all I have to do is draw a perpendicular line that forms a 90-degree angle, and this is the height. And it's the exact same thing. 1/2 base times height. All right. And I can even do this for triangles that look a little weird. So let's say I have this very concave triangle, or not concave, very obtuse. So let's say I have this very obtuse triangle, and we'll get to obtuse angles later, but we have this very basic like wide triangle or something. So I can still do 1/2 base times height for any side. I can still choose any side to be the base. I can even choose this side right here to be the base, even though you might say, well, you can't really draw like a height, right? Because you have to start from the opposite point. Well, you just still draw the height. You can draw the height outside of the triangle. That's still the height, right? The height is just how tall the triangle is. So if I'm measuring how tall it is, I can still measure it like this. And it's still 1/2 base times height. So let's say UMTYMP tries to trick you by saying, okay, you have to compare these two triangles areas. The first one is like this, and the second one is like this. And they're like, okay, so which one has a bigger area, A or B? And then you can be like, I'm not falling for that. It's C. Because they might try to convince you, or sorry, confuse you with the height that's outside of the triangle, but it still works. Okay. So I'm gonna go over one more thing. This is probably a lot more niche. It might not come up on the test, but it might. And that's the area of a parallelogram. So a parallelogram is still really simple. And I'm going to tell you that the area is base times height. It's just base times height. It's very similar to a rectangle, length times width. It's also very similar to a triangle, which is 1/2 base times height. And that's because a triangle is 1/2 of a parallelogram. So, so if the area of a parallelogram is base times height, what is the base and what is the height? Well, again, you can choose any side to be the base. And I'm going to choose this longer side here to be the base. And then the height, you just draw the height. Make sure it's perpendicular, and boom, we have the height. Okay. So Thanush, did you have a question that you wanted to share? I'm seeing that you said what, how to something. So is it the parallelogram or okay. The parallelogram? So why is it base times height? Okay. Well, again, you can use from the triangles, a parallelogram is two triangles, right? So you could just cut it into two triangles and they're identical triangles. So it's just 2 times 1/2 base times height, which is base times height. Or this is the actual proof. Do you see this like triangle right here that's created by the height? You see this like triangle right here? You can move that right here. It will be the exact same triangle. I didn't draw it very good, but it will be the exact same triangle because it's a parallelogram. And then now you basically have, if you move this, if you can visualize this, you move the left side to the right side, this triangle, then it's just a rectangle, right? And that's just base times height. So yeah. Okay. So I hope you guys are all familiar with these areas now. They're not too difficult. All the formulas are pretty short compared to previous weeks, right? So now I'm going to move on to something called the Pythagorean theorem. So maybe you guys have heard the Pythagorean theorem. It's a pretty famous theorem. It's probably the most famous theorem in math. But basically, the Pythagorean theorem states that if we have a right triangle, and remember, a right triangle is a triangle with any of the angles is 90 degrees. If any of the angles is 90 degrees, which is marked like this with this little rectangle thing, then it's a right triangle because it's a right angle. Right angles are 90-degree angles, right? And let's say the sides are A, B, and C. The Pythagorean theorem states that A squared plus B squared equals C squared. You guys probably already know this, probably heard this, right? And there you go. That's the Pythagorean theorem. But A, B, and C aren't just anything. C is the something called the hypotenuse. So the hypotenuse is the longest side. It's always the longest side in a right triangle. And the hypotenuse is also always the side opposite of the 90-degree angle. You see that? C is the hypotenuse, and it is opposite of the 90-degree angle. And the hypotenuse is always the longest side. And basically what Pythagorean's theorem tells us is that the first side squared plus the second side squared of the triangle equals the hypotenuse squared. So I would suggest you guys write this down if you don't have this ingrained in your memory already, because this is a pretty amazing theorem. It's very fundamental, very important for basically everything. Every math subject uses this in some way. Yeah, really. Even calculus. Calculus, name any math subject, it will use this. This is very fundamental, very important. So here we go. Pythagorean theorem. So remember, the hypotenuse is always the longest side, and it's opposite of the 90-degree angle. And the other two sides are called the legs. So the legs of the triangle are basically the sides that aren't are the sides that are not the hypotenuse. Okay, I'll give you guys a few more moments to look at this. It's a beautiful theorem. Well, the proof is too complicated for us to go to right now. But if you're interested, maybe you can search it online. If you search it online, you can probably find one, but it is not the easiest to understand, but it's a very important result. Okay, this is the Pythagorean theorem. So I can write it out, Pythagorean theorem. Okay. So something that's also important with the Pythagorean theorem is finding the distance between 2 points. Maybe you already know this, but let's say, let's say I have Bobby, right? Bobby is standing right here, and let's say Joel is standing over here, and we want to find how far apart they are, but we aren't given the distance. Instead, we're given like, oh, Bobby is 3 meters north of a lamp post. So here's the lamp post. And then Joel is 4 meters east of the lamp post. And now the question's like, okay, so what is the distance between Bobby and Joel? And you can figure it out using the Pythagorean theorem. So north and east, right? That creates a 90-degree angle. So there we go. We have a right triangle. So we can use the Pythagorean theorem. Remember the Pythagorean theorem, only right triangles, only works in right triangles, nothing else, only right triangles. And there we go. Now we can solve for our question mark, which I will call x. So that means 3 squared plus 4 squared equals x squared. And 3 squared plus 4 squared is 25. And then I know that 5 squared is 25. So x is 20. So x is 5. And boom, Bobby and Joel are 5 meters apart. That's pretty useful. Okay, so now I'm going to go on to circles, which are my favorite shape. And it might be Kevin's favorite shape too. Kevin, are circles your favorite shape?
No, I
What?
like rhombicosahedrons.
Oh, well. That's basically a circle, right? Nothing matches the epicness of a circle. So I want to hear you guys. So what do you think that a circle is? What do you think the definition of a circle is? I just want to have some thoughts out there. We all know what a circle is, but do we know what the definition of a circle is? So there's a lot of interesting definitions in the chat, and this is all true of circles. A circle does it kind of has infinite sides, right? But it also might have no sides, or it might, and it also kind of has infinite angles, but it might also have no angles. Yes, it does have an infinite amount of lines of symmetry. Well, I saw one correct answer by Feng Yu, and a circle is any point with a given radius. Well, that's a little bit of a confusing definition, right? So what is a point and what is a radius? Well, I'll demonstrate it for you. So let's say I just have a point, and this is the center of the circle. And let's say I have a radius, which is just a length, radius r. So to draw the circle, all I do is I spin this line segment around the point, and boom, I have a circle. This is a very terrible circle. Boom, I have nope, that's not good. All right, boom, I have a circle, which is a little better than before, but it's still pretty bad. But that's a circle, right? Just spin that. Basically, you can spin something around a point, and boom, you draw out the circle. So that's the definition of circle. But as you guys did point out, it does have many, many cool properties. First of all, the center is always the same distance away from the 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 outer edge, the circle part. And that is always the length of the radius. 你不吃饭？Something, 吃饭都没有了。Yeah. Okay. Something else that's also really neat of a circle is that it has infinite amount of lines of symmetry. Remember, a line of symmetry divides an object into two equal parts that are mirrors of each other. So if I draw any line through the center, I have a line of symmetry. Boom, that cut the circle into two equal parts. Boom, this also cuts the circle into two even parts. Okay, so now we know the radius is the length from the center to the outside part, but what about the diameter? What is the diameter? Well, the diameter is defined to be 2 times the radius. And that is basically, if you want to think of the diameter as a line, it's basically just any line that goes through the center of the circle. So here, I'm going to draw a bunch of diameters, and they're just all lines that go through the circle or through the center. And they're all diameters, and they all have a length of 2r. And they also happen to split the circle into two equally sized parts, and they're also lines of symmetry, right? So the circle's a lot of very cool things. So that's something called a diameter. It's just 2 times the radius. And now, let me ask you guys another big question. Do you guys know what pi is? So, so what is pi? Are you guys familiar with pi? What is pi? We know it's like it's a rational number, right? It has infinite digits, but what is it? It is 3.14159.265, blah 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 blah, right? That's the value of pi. But what is that definition of pi? Oh, I see it in the chat. The definition of pi is the circumference over the diameter. So we know what the diameter is, but what is the circumference? Well, the circumference is the perimeter of the circle. If we recall back to the start of class, the perimeter is where we just add up all the sides, right? Or you can basically think of it as if someone walks along all the sides, how many meters or miles does he walk? So if someone walks around this circle, how many miles does he walk? If the park is circular and I walk around the park, how many meters do I walk? And that's the circumference. It's the perimeter of the circle. Now, you probably have no idea how to calculate the circumference of the circle, but maybe you do. But how would you do it? You can't add up all the sides because there's an infinite amount of them. So the circumference of a circle, and I'm just going to give it to you because the proof is too hard. It requires calculus, but the circumference of a circle is is pi times the diameter. So that's where pi comes from. So pi is the circumference of the diameter, right? If you rearrange the equation, if you rearrange this equation, you get pi as the circumference over the diameter. But if you want to calculate the circumference, you do the diameter times pi, which is also 2r times pi, right? Because the diameter is 2 times r. So there we go. That is the circumference of the circle. So if you want to calculate the circumference slash perimeter of a circle, you use this formula right here. And maybe you might see it written as 2 pi r. Okay. And I see someone ask what the proof is. Well, it's a calculus proof, so it's not an easy thing. You could try to imagine it though, but it's pretty hard. To do it, you basically have to cut the circle into infinitely many small triangles, and then you'll add them all up, basically. That's also how you find the area of a circle. So now let's talk about the area of the circle. So if my swimming pool is circular, right? Maybe it's a hot tub, so it's circular. What is the area of the circle? Well, I'm just going to tell you it because the proof is very hard, and that it's pi r squared. So the area is pi r squared. So there we go. These are the two things you have to remember. You just have to know about circles. So circumference is 2 pi r, and the area is pi r squared, where r is the radius. So yeah. So there's where pi comes in. It's for circles. Boom. Okay. So I don't know if you guys have been scrolling on YouTube Shorts or TikTok or Instagram Reels or Xiaohongshu or whatever you guys use. Maybe you're scrolling on Google Chrome Shorts these days now. I don't know. But maybe you came across a video saying like, "Oh, my Uber driver was like, hey, they didn't have any 9-inch pizzas, so I got you two 6-inch pizzas." That's definitely more, right? You're welcome. Well, maybe you don't get it yet, but that pisses me off a little bit because guess what? Two 6-inch pizzas are not bigger than one 9-inch pizza. And let's see why. So can you guys tell me why that's not true? Why it's a scam, basically? So let's say I have two 6-inch pizzas, right? So these are 6-inch pizzas, and I have one 9-inch pizza. So if this is quantity A and this is quantity B, which one gives me more pizza? Well, yeah, you guys are right. It's B because if you calculate the area, let's do B first because it's only one circle. If I calculate the area is pi r squared. So and here r is 9. So it'll be pi times 9 squared, which is 81 pi. And if I go on to the left side, the radius is 6, so the area of one of these smaller pizzas is pi times 6 squared, which is 36 pi. And then I'll have two of them, so 2 times 36 pi is their area together, which is 72 pi. And that's certainly less than 81 pi. So that's why I get very angry with those YouTube shorts, which says that blah, blah, blah. Oh, you're not getting scammed. I actually gave you more food, but in reality, I guess many Americans just don't know how to do the area of a circle. So that's kind of unfortunate. So next time you order pizza, make sure you don't get scammed. All right. So I saw in the chat that someone wanted to post the proof of pi. So this is actually really interesting. So back in the ancient days, people didn't know what pi was. They knew that pi was the circumference over the diameter because that was its definition. They didn't know how to actually calculate that because you have to know their circumference. And to find the circumference, you have to know pi, right? It's an infinite loop. So they didn't actually know what pi was. And in the ancient days, to find pi, they had to approximate it. And what they would do is if you a circle is basically a shape with infinite sides, right? With infinitely small sides. So taking inspiration from that, they just drew out a very big polygon, a very big normal shape with just so many sides, like maybe like 3,000 sides. They just draw a shape with 3,000 sides, and then they use that to approximate pi. And it was, as you can imagine, it's very difficult, very tedious to calculate pi, and it's not even that accurate. It isn't until Isaac Newton that we use calculus to find the value of pi. So that's a cool history part of pi. So it's a great number, right? 3.14. All right. So now let's talk about maybe like fractions of circles. So let's say I have a circle and it has a radius of 3. So what I want you guys to do is there's going to be 4 questions, okay? So you guys can answer this in the chat. The first one, I want the area of the circle. So I just want the area of the circle. The second one, I want the circumference of the circle. And the third one, I'm going to cut this circle like this. I'm going to cut the circle into a quarter. So I want you to find the area of this quarter circle. And then I also want you to find the circumference of the quarter circle. So go ahead and put your answers in the chat. All right, well, let's go over it. So I hope you guys can at least do questions 1 and 2, right? And to answer your questions, Bars, yes, you can just divide by 4. So let's just go over question 1 and 2 first, because I hope you guys can do that, right? The area of the entire circle is pi r squared, which is pi times 3 squared, because the radius is 3, which is 9 pi. And the circumference of the entire circle is 2 pi r, which is 2 times 3 pi, which is 6 pi. So those should be pretty easy to do, right? But for the quarter circle, this quarter circle right here, well, that's a little harder, right? But as Sparse mentioned, you can just divide by 4. It is a quarter circle after all, so it has 1/4 of the area and 1/4 of the circumference. All right, isn't that cool? With other shapes, if you have a quarter area, you don't necessarily have a quarter of the perimeter, but for a circle, you're guaranteed that. If you have a 1/16th of the area of a circle, you also have 1/16th of the circumference.
Okay, but so for the circumference, we do have to be careful about just dividing by 4 because we see that this side over here, let me change color to make it more clear. We see that this side over here is indeed 1/4 of the circumference. So this would be 1.5 pi. But since we cut the circle, we have introduced 2 new sides. So the circumference or perimeter is an equally appropriate word,
Oh yeah,
also includes
sorry, yeah.
these 2 sides.
I was not completely clear. When I meant the circumference of the quarter circle, I meant I meant sorry, the arc length, sorry. So just the curvy part basically. So sorry, I should have said the arc length. This is called the arc length. That's my bad. Yeah, if you want to find the circumference slash perimeter of the entire quarter thing, you would have to add the two sides here as well, which isn't that hard to do, right? You just add 6, the radius twice. So good job, Kevin, for pointing that out. That was a bad mistake on my part. Okay, but let's go ahead and calculate those things though. So the idea still stands, dividing by 4. So for the area, we do divide by 4, and so I'm just going to divide the first one by 4, so we get 9 over 4 pi. And on the for the last question, the circumference of the quarter, or slash the arc length, sorry. So if I want the arc length, it's going to be 6 divided by 4 pi. So 3 over 2 pi. And if I want the entire perimeter, then I will add. So let's say I have a question 5 now. If I want the entire perimeter, as Kevin pointed out, yes, I will have to add the 2 radius stuff. So it'll be 3 over 2 pi plus these 2 extra sides, which are just the radius. So plus 3, which is plus 6. Okay, that's great. And here, let me clear the annotations. Okay. And this doesn't only work for quarter circles, as I pointed out earlier. This works for any fraction if you want. So, in fact, the fraction is actually defined by an angle. And Kevin will go into angles later, but if I have some angle here, I can use the exact same relationships to find everything. Okay, so I'm going to pass it on to Kevin to go over the second half of today's lecture.
Okay, let me share a whiteboard really quick. Okay, cool. Wait, give me a second to pull up the handout. But the first thing is going to be angles. So, so what an angle is how we measure how wide, like, the measure between two lines is. So if we had these two lines here, this angle measures just like how wide that gap is. I'm not sure how to word this to make it the most clear, but yeah. So essentially, how you would do this is you consider how much of a circle it takes up. So that's a really bad circle, actually. I should change that. If I was more artistic, maybe this would be a better explanation, but that's still. But what this angle measures is what portion of this circle is kind of like caught between these two lines. So traditionally, because the Babylonians used the base 60 system, this is out of 360 degrees, or you'll learn in geometry, you might use out of 2 pi radians. But we're just going to work with degrees here because that's primarily what your UMTYMP exam is going to deal with as well. So essentially, how a degree works is a full circle is 360 degrees. That would be like that angle that goes around the entire thing is 360 degrees. For a smaller one, it's just the fraction out of 360. So like, for example, let's say this is 1/6 of the circle, right? Then the angle here would be 360 degrees over 6, which would be 60 degrees. So this would be 60 degrees. Now, for some types of angles, we have acute angles, right angles, obtuse angles, and straight angles. Yeah, I'm not sure what the other one is called. But essentially, an acute angle is one that is less than 90 degrees. So like, let's say it's 30 degrees. That is an acute angle. It's like a sharp turn. And you can remember that because it's like a small angle, so it's very cute. It's a cute angle. And then a right angle is exactly 90 degrees. It won't, instead of writing the circle with the 30 degrees, it'll draw a little square, and this means 90 degrees. And as Aaron mentioned before, this is useful in things like right triangles, where you might have to apply the Pythagorean theorem. So if you see a triangle with a right angle, Pythagorean theorem should be one of the things that jumps into your head right away. And then lastly, or pretty much lastly, we have obtuse angles, which are between 90 and 180 degrees. This one looks close to like 135. And they're wide. So obtuse is just like a pretty large sounding word. So yeah, I guess that's just how you remember it. Or just remember it as the one that's not acute or right. And then lastly, a straight line. This is 180 degrees, or a straight angle, it's sometimes called. But essentially, it's just half of a circle, right? Like this would be a half of a circle, and then this would be another half. So this would be 180 degrees, and the total would be 360. And then, yeah, I'm not sure. I don't think this has a name. It might be reflex angle, but there are some angles that are greater than 180 degrees. But they're not really important. Like the name's not really important. But yeah, if you had like a 195-degree angle or something, that's, I think it's a reflex angle. But you'll see those very rarely. These three are the most common, which would be acute, right, and obtuse. So one important thing here would be like, if two angles make a straight line, like let's say this is 20 degrees, then the total has to be 180 degrees. So it might ask you to find an angle based on this. It might be like X as one of the options. And then here you would see, oh, it's a straight line. So the total has to be 180 degrees. And this part is 20 degrees. So this part has to be 180 degrees minus 20 degrees, which is 60 degrees. No, 160 degrees. Oh my God. Okay, 160 degrees. And so we're going to go over some properties of angles. So first of all, if you have these two lines here, this angle and this angle will always be the same thing. You can prove this pretty quickly. Let's say this angle is x degrees. Then, since this is a straight line, we see that this has to be 180 minus x degrees because they have to add up to 180. And then looking at, I'll recolor. Looking at this straight line, we know that this angle and this angle have to add up to 180 degrees as well. So then this angle would be 180 minus 180 minus x, and that is x degrees. So for any two lines, these two angles are always the same. So, and this property is called the vertical angles. You shouldn't really need the name, but it's always good to know. Now for a more complicated ones, a lot that angles have to do with are parallel lines. So do you guys know what parallel lines are, first of all? Go ahead and, if you know, go ahead and say it in the chat. Right, so Tanish gave us a definition of lines that never touch. And that is a definition that works. So essentially they're lines that move in the same direction. And because of that, they'll never get any closer to each other, and so they'll never touch. So these are parallel lines. Uh, there's a notation for this, I think. Oh yeah. If you see two lines and they have these arrows, it'll show that they are parallel. So what is the relation between parallel lines and angles? There are a lot of properties that have to do with, like, there are a lot of angle properties that have to do with parallel lines, just because parallel lines go in the same direction and angles are all about directions. So the first one is called alternate interior angles. It's a bit easier to demonstrate with this diagram. So these two are parallel. And then, oh, a line that cuts through them is called a transverse line. You don't really need to know that either, but it's a fun piece of trivia. So basically, alternate interior angles says that this angle and this angle are the same. So, wait, let me see if I can remember the proof for this. So essentially how you do this would be like, yeah, the vertical angles are the same as well. That's true. But how you would do this is, I don't think I'm allowed to use triangles yet.
Or you
Okay,
have to
we're
use
going to come back
diagram,
to this
or
in a
you have to
second.
use a parallelogram.
Yeah, a parallelogram or a triangle. But we'll get back to that after we explain those. So just take this for granted for now, and I'll explain why after I get to triangles and parallelograms. So first of all, the sum of angles in a triangle is 180 degrees by definition. So you have A, B, C, then A plus B plus C in degrees equals 180. And then for any polygon, the sum of the interior angles is going to be 180 times the number of sides minus 2. Yeah, is there going to be the sum of, so like for a triangle, when n is 3, it's 180 times 3 minus 2, which is just 180. But for something like a quadrilateral, which includes squares, rectangles, parallelograms, rhombi, kites, trapezoids, it would be 180 times 4 minus 2, which is 360 degrees. So a question might ask you, like, what is the total degree? Like, one of the quantities might be the total degrees in the inside interior of a nonagon, say, for instance. A nonagon has 9 sides. Well, it'd be 180 times 9 minus 2, which is 180 times 7, which is 1,260 degrees. So you could find that quickly. However, for like a regular, oh wait, this is a pretty deep rabbit hole. Yeah, we're gonna stop there for now. We'll explain polygons in a different class. So knowing this triangle property and this parallel, oh wait, that feels like a bad idea actually. So yeah, knowing this triangle property, we can go ahead and prove our alternate interior angles. So we're gonna draw an altitude there, making this a right triangle. And we know that these three angles have to add up to 180 degrees. So since this is 90 degrees and this is x degrees, that has to be 180 minus 90 minus x, which is 90 minus x degrees. So we know this is 90 minus x degrees. And we also know that, wait, this is actually a really annoying proof without citing itself. Okay, we'll just take it for granted that this is also 90 degrees. But yeah, this is a property of parallel lines. So anyways, this is 90 degrees. And so this whole thing has to be 180 degrees as well. So this angle must be 180 degrees minus 90 minus 90 minus x. And we see that this is just x degrees. So this is alternate interior angles. I'll restate it again. If you have these two parallel lines, this angle is equal to this angle. So one last property that follows from these two, we know by vertical angles that this and this are also the same and are x degrees. So there's something called corresponding angles, which says that these two angles are the same. And you'll see that that just comes from our alternate interior angles and the vertical angles. Yes, Tanav? You can unmute yourself and ask if you have a question. Nothing? Okay. I'll just keep moving with the angles then. Okay, so yeah, sum of angles in a polygon. We have this formula from before. And we should go into a few more specific cases. So do you guys know what a regular polygon is? This might be a new term for some of you. If you know, feel free to say it in the chat. Yeah, so Aaron gave us the definition. A regular polygon is a polygon where every angle is equal and every side length is as well. So for example, this is a regular hexagon. And yes, Nanav?
So basically, could you I was just wondering why would we use the pi formula in
The
real?
pi formula?
Yeah, like just like 3.14. Why would we use that in like real life?
Okay,
Well, in
so
real life, oh wait, go ahead,
yeah, so
Aaron.
pi is basically just used to find the circumference of a circle and the area of a circle, right? The circumference is the pi times the diameter of the circle, and then for the area of a circle is pi times the radius squared. So that's how you would use it in real life. So let's say you're walking in a park, right? And you just want to know how many miles you walked. If your park is a circular park, then you can find it, right? Finding the circumference. Or if you want to paint a wall and you want to paint a circle on the wall, then you can know how much paint to buy, right? Because you have to cover that much area.
Yeah. Another question. Could you show me it is like the circumference is the outside. The radius is from the middle to the outside. The diameter is like that whole like the symmetrical line, right?
Yes, that's all correct.
Okay, thank you.
Yep.
Okay, great. So back to regular polygons. We know all of these side lengths are the same, and we know that all of these angles are the same. So both of these are required for a regular polygon, and one of them does not necessarily follow from the other. For example, we could have this stretched hexagon where all angles are the same, but clearly the sides are not. Or we could have an equilateral hexagon, which has all side lengths the same. Oh, that's a bad drawing. All side lengths are the same, but these angles are not. So yeah, a regular polygon has all angles equal and all side lengths equal. And so that means we can find the interior angle for a regular polygon. So using this formula, can you guys tell me the interior angle measurement of a regular hexagon as shown here? And go ahead and put that in chat. So like the measure of a singular angle, what is x? Yes, so I see some correct answers in chat. The correct answer is 120 degrees. So how we would do this is we would find the total of the interior angles first of all, which we know is 180 times 6 minus 4, or 6 minus 2. Got ahead of myself there. And then we would divide it by the number of angles because each of them has an equal amount. So divide by 6. And this is 180 times 4 over 6, or 120 degrees. And so, yeah, that should be all we have on polygons. They might ask you for this on the UMTYMP exam, but they might give you a much crazy, why divide by 6? Oh, okay, because the total is 180 times 6 minus 2, right? So that's 720. But we want to know the angle measurement of one of them. So like each of them, and we know each of them are the same. So we have to split 720 degrees equally among these 6 angles because a hexagon has 6 angles. A hexagon has 6 angles. That's why we're dividing by 6, because we're splitting the total of 720 equally across these 6 angles. So yeah, but like in the UMTM exam, they might ask you, oh, what's the interior angle measurement of a what's a good number? I don't know the prefix for 20, but a 20-sided polygon. What is the interior angle or regular 20-gon? What is the interior angle measure? I'll let you guys try that too. So remember the formula 180 times n minus 2 for the total angle measure. So yeah, Ethan, that is correct. Great job. The correct answer is 162. And how you would do this is you would take the total of the interior angles, which is 180 times 20 minus 2, and you would divide it equally among the 20 angles. So 180 times 18 over 20 is 162. So we're going to move on to some miscellaneous geometry things that you might need for the UMTM qualification exam. Uh, Aaron, do you want to do scaling shapes? I'm not quite sure what you wanted me to go over with that.
Yeah, sure. So, am I able to draw on your whiteboard? Do you see that?
Should be able to.
Okay. I don't know why it's so gray though. Why is it so gray? Okay. Well, so basically, yeah. Yes, Lanav?
So basically, I just wanted to like go over like the parts that you said. So I was just like wondering. So like I have like a shape that's like this, and like it's like this. And you said I could just move the sides here and like that for like the perimeter, but like
Yes.
that would make the whole shape different for the area, right?
Yes, that would.
So how do I find the area? Do I need to like is it like manual? Like I need to break down the shapes and like find it like each of those shapes and then add them up, or how do
Yes,
I do it?
that's exactly how we would find the area.
Oh,
You have to break it up into smaller shapes that you know the area of, which are ideally either triangles or rectangles.
okay, thank you.
Yep. Okay. So you guys can see what I'm drawing. I don't know if Zoom has this feature to follow people, but yeah. But let's say I have some triangle, right? With these measurements. And let's say I have another shape with these measurements. And let's say UMTM says, okay, these are the same shape. Now what's bigger? X or 7? They want you to compare X or 7. And I'm not going to get too deep into this, but basically the second shape, right? This shape right here is just a scaled up version of the first shape, which is, so that means every side would just be 2 times larger than the first shape, which means that X would be 8. So this would be A. So this is something called similar triangles, and that's a little bit too deep for the test, but they might have some questions like this. But you can, if you think that that the shapes are just scaled up, you can apply this property. All right. So another thing I want to go over is that let's say UMTMP is like, okay, a circle and a square have the same perimeter, okay? They have the same perimeter. And they're and what A is, quantity A is the area of the circle. Quantity B is the area of the square. So which is bigger, A or B? And remember, UMTYMP says that assume that the circle and the square have the same perimeter. And the answer is actually A. So for any given perimeter, if you want to maximize area, you want to be as close to the circle as possible. So if the perimeters are the same, the area will have a larger circle than the square. I mean, not the area. The circle will have a larger area than the square. And likewise, if we have a hexagon versus like a pentagon, if they have the same area, the hexagon will have more area than the pentagon. And if we go the opposite way around, like let's say we have a circle and a square with the same area, the circle will have a smaller perimeter than the square. So that UMTM might try to get you there. And the reason why is you can think of it as if you have a circle, you're basically packing as much as you can, right? Because if you think about areas, basically you can think of it as like a bunch of little dots just packed together, right? You're packing as much stuff as you can as close as possible, which is why it looks like a circle. That's also why the Earth is a sphere. And then for a square, you're not necessarily doing that. So yes, Lanav?
So basically, I'll just like draw a circle here, and maybe that's perfect. And I'll just draw like maybe oh my god, a square, like right around it, kind of like this.
Okay, yeah.
Except like the squares, the circles in it, and all the sides are touching. So then, would that mean that the square's area would be bigger or the circle's area?
Yeah, the square's area in that case would be bigger, right? Just you can like look at it, right? The square, um, the circle's inside the square, so the square has more area, but they don't have the same perimeter in that drawing, so it
Yeah.
wouldn't apply to this question.
Oh man. So if I shove your circle into your own square, then that same case comes there. So would that mean that B would be greater?
No, because the condition in my question was that the perimeter was the same.
But if the wait, if the perimeter was the same, then
No, that
what
was
is
like that was like given, like it was like assume that the circle and the square have the same perimeter, and then they want you to compare the areas.
okay?
Yeah,
Yeah, thank you.
yep. So that's a great question. So yeah, that was so when I say the perimeter is the same, that's if the umpteenth question says that they're the same, and like, oh, now I want you to compare the areas. So that's what you would do for that. Okay. So now let's just talk briefly cover. We are a little bit running a little bit late, so I will briefly cover surface area and volume. So surface area, so this is for 3D shapes. So we know 3D shapes, right? Like a cube. And if we have a cube over here, the surface area of the cube is the area of all six sides added together. And that's exactly how you would calculate it. So if the cube has side length 1, then you have to find the surface area of each face and or each individual square. There's 6 of them, and then you have to add them all together to get the final surface area. And then for volume, it's how much space something occupies. For a like a rectangular prism, it's length times width times height. So it isn't too much different. Okay, so I hope that's pretty intuitive. There's I'm only going to cover for rectangular prisms. For other things, it's a little bit harder. But generally, if you have like a prism, like something like this, maybe, right? Like you have a triangular prism, something like that. The area is the base times the height. The area of the base times the area of the height. Don't confuse this with the area of a triangle, which is yes, sparse?
How do you do the area of a cylinder?
Of what?
A cylinder,
A cylinder, like the surface area or the volume?
the volume.
The volume?
Yeah.
Okay. So a cylinder is basically a circular prism, and if we apply the concept of the triangular prism up here, all we do is we to do the area of the bottom shape, like the base shape, basically, times the height. And for a cylinder, we know that the area of the base shape, which is a circle, right? You can think of a circle as a bunch of small cylinders, or you can think of a cylinder as a bunch of small circles stacked on top of it, right? Like a bunch of chocolate chip cookies stacked on top of each other makes a cylinder. So the area of the base is pi r squared, right? That's the area of a circle. And then whatever the height is, if you multiply those two together, you get the volume of a cylinder. Okay, so that's all we have to cover today as a lecture. So now we're going to begin the mock test. So if you guys head over to Google Classroom, um, you guys should be able to see the mock test now. Please let me know if you are unable to see it or if it's the wrong one, but it should be posted now. Mock test 3 should have the PDF of the mock test up as well as the Google Forms Scantron. So it's 50 questions, 30 minutes. So let's go ahead and begin the timer. And due to the fact that we're low on time today, we will only be reviewing the even problems. So just keep that in mind. All right, let's get a timer up and let's get started. I'll give you guys 2 minutes to download it and do everything, and then we'll begin the timer. And as Ethan said, the answer key might have had a few mistakes, so it should be fixed now. So go ahead and see what you guys got. If you want to share, you can feel free to share it. If not, that's fine. But now we're gonna go ahead and review. So it is almost 9, so we have to keep this review quick. So if everybody could put 3 questions that you want to see reviewed in the chat, just type out the numbers. We will be sure to review all of them. So everyone type 3 questions that you want to see reviewed and we will review them. So again, everyone type in the chat which questions you want to see reviewed. Type like 2 or 3 and we will review them. Okay, well, I will just choose some problems then that a lot of people missed, and we'll go off of that. So, okay. So, the question 46, we only had one person get that right. So, the question asks for the amount of degrees in a circle versus the amount of degrees in a diamond, which is basically just a rhombus, right? A diamond is is a shape with 4 sides. Kind of looks like a sideways square. And a circle is like this. So the question asked how many degrees are in a circle versus how many degrees are in a diamond. Well, we know there's 360 degrees in a circle. And there's also 360 degrees in a diamond, so the answer is C. And the reason why there's 360 degrees in a diamond is because if you apply the formula Kevin taught you guys, right? 180 times n minus 2. We see the n is 4, so we have 180 times 4 minus 2, which is 2, and we get 360. So 46 is C. Now, for the next one, let's review question 38. Okay, so question 38. This question is a little bit unclear, but I'm pretty sure it's asking for the area. So if we scale up a triangle by 2.4, the area, well, the triangle gets bigger, right? So obviously the area will increase. And if we scale it up by 2/3, well, that will make it smaller because 2/3 is less than 1. So 38 should be A. And yeah, A is the correct answer. Okay. Now let's go over question 35. So we didn't learn why X and Y intercepts yet, but basically this is something you have to graph on the XY plane. So if I do that, I guess I'll just have to do it on the question. But if I do it like this, and by the way, if you're wondering where Aditi and Eric are, they are on vacation today, and Aditi is actually at a competition called HOSA, so maybe cheer him good luck, right? Hopefully he wins that. Hopefully he wins that, but that's why he's not here today. But anyways, back to the question. So question 35, if I graph this, it looks something like this. Um, and where 5/3 is the slope, and -4 is the y-intercept, and the x-intercept is this positive number here. So the answer is B. But this question is hard. We didn't teach it yet, so no worries if you missed that one. Let's go over question 32 now. Question 32 asks for the volume of a cylinder. Okay, so question 32, I'll let Kevin take this one.
Okay, so volume of a cylinder versus surface area of a cylinder. So volume of a cylinder, Aaron did go over briefly at the end there. And we know that it is, I'm sorry. Let me change my color. Actually, red might be better for this background. We know that the volume of a cylinder is pi r squared h. So what is r? R is the radius, which is half the diameter. So r equals 4/2 equals 2. And it's given that the height is 8. So volume equals pi times 2 squared times 8, which is 32 pi. On the other hand, surface area, I don't think Aaron covered this, so we'll go over it really quickly. For the surface area of a cylinder, you have to consider three things. You have to consider, well, a cylinder, first of all, looks like this. You have to consider the circle at the top, the circle at the bottom, which is the same circle, and the outside of the cylinder, which is called the lateral surface area. If you unroll it, it's a rectangle. And so, first of all, the area of each of these is going to be pi r squared. So that's 4 pi and 4 pi as well. And then for this rectangle, it's a little bit trickier. If you think about it though, this long length is going to be the circumference of the circles, right? Because when you unroll it, that length is just like what's around here. And the height is still the height. So the height is 8, and the side length is 4 pi. So the area here is 32 pi. So the total surface area is 32 pi plus 4 pi, which is 36 pi. And this is greater than 32 pi. So the correct answer here would be B.
It would be plus 4 pi, right? For
Oh,
44.
wait. I don't know. Yeah.
But either way,
I
it's
thought I doubled already, but it's greater anyways. Yeah.
okay. Now I see Molly wanted to review 6, 8, and 13, so let's go up to 6. So the area of a triangle with 6-inch dimensions on all sides, and an area of a right triangle with 6 by 3 inch dimensions. So this one did have a clarification. For question B, the 6 by 3 is the length of the sides. So on the left side here in this gray area where I'm drawing these little swirls, um, I'm going to explain quantity A. So quantity A, the area of a triangle with 6-inch dimensions on all sides looks something like this. And quantity B would be like this. So I can find the area of quantity B pretty easily. It's 1/2 base times height, which is 9. And over here, this is something we haven't quite covered yet, but I can give you it now. The formula for a regular triangle, which is basically just an equilateral triangle with where all the sides are the same, is square root of 3 times the side length squared divided by 4. Um, and yeah, so this problem is a little bit tricky, but if you look at it, um, never mind, that won't work. Okay, so yeah, you just basically have to use this, and then we end up finding that the area is 36 over 4 square root of 3, which is 9 square root of 3, and this is bigger because square root of 3 is greater than 1. So yeah, 6 is definitely a hard question. If this were to appear on the real test, it'd be one of the hardest questions. Okay, and then number 8, I'll have Kevin go over this one as well. Yes, enough?
How do you find the? I forgot how. Like, how do you find the area of an equilateral triangle?
Okay, I'll keep the formula on the screen, but I really don't expect you to know it. That question should have been tossed. It's too difficult. But if you're just curious, here is the formula.
Oh, will we like learn it in like the upcoming classes?
You'll learn this in UMTYMP itself, but this is probably too hard for that entrance exam. But if you want to know what it is, it's this. And if it says C, it shouldn't be C.
Thank you.
So, what was the correct answer for that
The correct
question?
answer should be A.
Okay, there was a mistake then.
Okay, so question 8, right? Sum of the interior angles of a rectangle or sum of the interior angles of a trapezoid. So a quick way to do this would be to notice that both have 4 sides. And the formula for the sum of the interior angles only depends on how many sides there are. 180 times n minus 2, right? So there you're done. You know it's C because they have the same number of sides.
Yep.
If
That's a
you,
great way to do it.
yeah.
That's a great way to save a lot of time. Okay, so now let's go over uh sorry. Let's go over 13. Okay, so Grant took a walk around the park. So this one also had a clarification. Length of the park. This should be the side length of the park in feet. Okay, so we know that Grant walked 4 miles in a square park. So the length of one side of the square is 1 mile. And on the other side, we have 5 to 70 feet. Now, I don't expect this you know this because I don't know it myself, so I'm going to Google it. But we basically just have to convert 1 mile to feet. And if you ever have to do this on the real test, they should give you the value, but we see that it's 5 to 50. So if I go back here, this will be 5 to 80. Well, yes, not 5 to 50, 5 to 80 feet, and that's bigger than the other one. So this would be A. Okay, well, it is nearing 9 o'clock now, so if any of you guys have to leave, you guys can feel free to leave. We will review 3 more questions though, and then we will go ahead and end today's class. So let's see. So question 3 was frequently missed. Let's see what that one was like. Ah, yes. Okay. So Kevin, do you want to review question 3?
Yeah, sure. Okay, so interesting. Okay, so we see that a is -2 is less than or equal to the square root of a is less than or equal to 5. So first of all, the negative restriction is kind of redundant because we know that square roots are defined to be non-negative. So really it's 0 is less than the square root of a is less than 5 or equal to 5. But that doesn't really matter. What we want to see here is the edge cases, first of all. So a good way when you see like a variable and an inequality is to test the edge cases and see what they give, because normally everything inside should like fit with the edge cases. So like if the edge cases work, it's likely that all of them work. Don't take that for 100% granted, but it's a good guideline to go by. Yes, Tanaf?
Like, I just wanted to ask, like, the UMTYMP prep, like, not the UMTYMP prep, like, the entrance exam, like, is it, like, digital, like, how we do it, or it's on, like, paper?
It should be on paper.
Probably on paper, unless they've changed it recently. It'll be on paper.
I think last year's was on paper, so I think this year should also be on paper.
Oh,
S-
yeah.
So our edge cases would be square root of a is equal to 5 and square root of a is equal to 0. So for the second edge case, obviously a is just 0, which would give us an answer of a. But for the first one, if square root of a is 5, then a equals 25, which would give us an answer of c. So since the answer is ambiguous, the correct answer is D.
So that's a beautiful explanation. Okay, so let's see another frequently missed question. So question 5. Okay, so question 5 uses the Pythagorean theorem. So um, these two names are different, but they are supposed to be the same. So yeah. Um, okay. So this question, we know that it's not D because we can actually calculate the distance between these two people, and it's kind of similar to the example we did in class. So if Jason, so let's say I have the mailbox right here, denoted as M, and then if Jason is standing 5 feet north of the mailbox, and then Daniel is standing 3 feet east, then we want to find the distance between Jason and Alex, and we can go ahead and apply the Pythagorean theorem. So we see that the distance between Jason and Alex, which I'll call x, from the Pythagorean theorem, x squared equals 5 squared plus 3 squared. And that is 25 plus 9, which equals 36. No, 34. Okay. So that means x equals the square root of 34. And we know that the square root of 34 is less than the square root of 49, which equals 7. So in this case, the answer would be B. Okay. Let's go over one more, and then we'll go ahead and end today's lecture. Let's go over question 32. Oh, no, we already did that one. Okay. Question 38, maybe? Oh, we did that one as well. Okay. Question 23. Did we do that one?
How about question 35? Did you go over that one yet?
Question 35. Oh, yes, I did. Question 21. Oh, yeah, let's do question 21. So, Kevin, would you like to do this one?
Yeah, sure. So this is from last week's content, number of factors of a number. So the key thing to do here is, if we remember, the important thing when we're finding the number of factors is to find the prime factorization. So for 1024, we start by noticing that it's an even number. So we divide it by 2. We notice that 512 is also even. We divide by 2 again. And since we keep getting even numbers, we'll just keep doing this. I'm gonna run out of space on that side. And we notice that we've finally reached only primes. So we count up our 2's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know that the prime factorization of 1024 is 2 to the 10th power. And so we know the formula for the number of factors is to take the power of each prime in the prime factorization, add 1, and multiply all those numbers together. Since there's only 1, the number of factors is just 10 plus 1, which is 11, and greater than 10. So the answer is A.
All right, so that will concludes today's class. So thank you guys all for coming. If you guys have any questions that you would like to ask us, maybe about next week's class or today's content, we'll be happy to answer them right now. But otherwise, you guys are free to leave and have a great rest of your evening.